Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In the last video, we did an example on basic concept of probability density function. Today, we will take one more example. But before we start, a small request. After watching this video, if you find that the video was useful, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with today's video. Let's read out the question. What the question is saying? The continuous random variable x has probability density function given by f of x is equal to k for the interval -2 to 3, where k is some constant, and f of x is equal to 0 otherwise. And what's the first part they are asking? They are saying sketch the probability density function of x. So that means they are telling you to plot this particular graph, y is equal to f of x. So what do we know about probability density function of x? That the graph of y is equal to f of x will be always above the x-axis. That means f of x cannot take negative values. It cannot go below the x-axis. Second thing, that the total area under the curve of f of x is always equal to 1. Correct? So here y is equal to k means it is a line parallel to the x-axis, and because k has to be positive, so that means it will be a line parallel to x-axis above the x-axis. Correct? So let's try to plot this particular graph. Let me bring a grid here. Let's try to plot the f of x axis and the x axis. F of x versus x is 0, 1, 2, 3, 4. This is -1, -2, -3, -4, and so on to the left. Now f of x is equal to k only for the interval -2 to 3. So that means it will be a straight line from -2 to 3. Okay, parallel to the x-axis. Beyond 3, f of x is 0. So that means it will be a line on the x-axis because f of x value is 0. And to the left of -2, f of x is also 0. Correct? So that means f of x is only for this interval from -2 to 3. So let me draw a dotted line here just to indicate that f of x is only for this interval. Let me make it dotted. Okay, so this is our graph of f of x, and here I will have to put the value of f of x for -2 to 3. What is the value? The value is k. Okay, let me group this. So this is the particular graph of probability density function of x. Now they are asking find the value of k. So how do we find out the value of k? As we know that the area under the graph has to be equal to 1. Correct? So that means I can integrate f of x from -infinity to infinity, that is for all real values of x, and this integration has to be equal to 1. Correct? But I can split this interval from -infinity to infinity into 3 parts. What is the first part? From -infinity to -2. Correct? Then from -2 to 3, and then from 3 to positive infinity. Why did I split this up? Because for -2 to 3, f of x is taking some different value, and for rest of the values of x, f of x is taking some different value. What is the value it is taking from -infinity to -2? It is taking a value 0. So that means this total integration will be equal to 0, correct? Plus here from -2 to 3, what is the f of x value taking as? It is taking a value k. So I can say this is integration of k with respect to x when x is varying from -2 to 3, plus for 3 to infinity, f of x is taking again value 0. So that means here the integration value will be equal to 0, and this total integration will be equal to 1, correct? So this means if I have to integrate this part, k being a constant, I can take outside. So it is integration of what? It is integration of 1 with respect to x, correct? So what do I get this as now? This integration will be x, and the limits of x is from -2 to 3, correct? So let's try to put the limits here. It becomes 3 minus of -2. This is equal to 1. So here what do I get? I get this is k times 5 is equal to 1. It means k is equal to what? 1 by 5, which is nothing but 0.2. Correct? We can find out this value of k using the definition also. What is the definition of probability density of function of x? That the area under the graph has to be equal to 1, correct? So if it is equal to 1, so I can use the geometry here. This represents a rectangle, correct? The length of the rectangle is nothing but 5, and the width of the rectangle is k. So that means k into 5 has to be equal to 1. It means k has to be equal to 1 by 5, which is equal to 0.2. So many a times the geometry helps us to find out the value of unknown, okay, much faster compared to the integration. So this answers the second part of the question also. This was the first part. It answers this is the second part here. Let's go to the third part. What is the third part they are asking? They are saying find the probability of mod of x being less than 2.5. So you might have studied in Pure Math 3 that mod of x being less than 2.5 means x is less than 2.5 or x is greater than -2.5, correct? So x has to lie between these two values, correct? So probability of mod of x being less than 2.5 is equal to probability of x lying between -2.5 and 2.5, correct? So I have to find out this particular probability. So this particular probability, that means I have to find out for this particular interval the area under the curve, correct? So I'll again integrate the curve, that is I'll integrate f of x now only for this interval. What is the interval? From -2.5 till 2.5. Yes or no? But I know that the curve is defined with some finite value, with some non-zero value from -2 to 3. From -2.5 to -2, f of x is 0, correct? So here I will have to split this integration again, the limits, into two parts. One is from -2.5 till -2, and from -2 till 2.5. correct? So if I split this interval now from minus 2.5 to minus 2, f of x is 0. So this value here will be 0, plus from minus 2 to 2.5, f of x is taking a value equal to k, and k is how much? 0.2, correct? So that means I am supposed to integrate from minus 2 to 2.5, 0.2 with respect to x, correct? So what do I get this as? 0.2 I'll take outside, and integration of x will be what? Integration of 1 with respect to x will be what? X, and the limits is from minus 2 to 2.5. So what do I get this as? This becomes 0.2 into 2.5 minus of minus 2. So this in turn becomes 0.2 into 2.5 minus of minus 2 is 4.5. So this is into 4.5, and this in turn becomes equal to how much? 0.9. So can I say probability of mod of x being less than 2.5 is nothing but 0.9, correct? So this answers the third part of the question. Now they are saying for the fourth part, given that x is greater than 1, find the probability that x is less than 1.5. So they are asking for a conditional probability here. Okay, let me take the screenshot of this sketch. I will require it. Okay, there is no space on this page. Let's go to the next page. So here in this particular graph, okay, they are asking to find out what? Probability of x being less than 1.5 given that x is greater than 1, correct? So probability of x less than 1.5 given that x is greater than 1. So they are asking for this particular probability. So how do we find out this particular probability? So x greater than 1 is what? From x greater than 1 means they are asking from 1 to 3, because for the rest of the values to the right of 3, okay, f of x is 0. So that means they are asking for this particular area here, correct? So this is given that x is greater than 1. So if x is greater than 1, then what is the probability here? Let's try to find out that probability. Probability of x greater than 1 is equal to what? It is equal to this area. So this area I can find out using the integration or using the geometry here. That is from 1 to 3 I will integrate f of x dx, correct? Or I can use the geometry also. What is the geometry I'll use? That this is a rectangle with a length equal to 2 and the width is equal to k, but k is 0.2, correct? So this is 2 into 0.2, which is nothing but 0.4. Now for this particular given area, they are asking x has to be less than 1.5. What is that particular probability, correct? So let me copy this again. So they are asking for this particular region from 1 to 1.5, correct? Given that x is greater than 1. So they are asking for this particular area here. So this particular area is actually the common part of this area and this area, correct? So probability of x less than 1.5, the intersection I'll try to find out with x greater than 1, correct? So this intersection, if I try to find out this particular probability, I try to find out. So what will be this? It will be only this area, correct? So this area is equal to how much? This area is equal to 0.5 is the width, length here, and the width is equal to 0.2. Correct? So now this conditional probability, you might have studied in stats 1 that this conditional probability is equal to what? This is equal to probability of the common part divided by probability of the given part. What is the given part? Probability of x greater than 1. Correct? That is given. So probability of x less than 1.5 given that x is greater than 1 is equal to probability of x less than 1.5 intersection x greater than 1 divided by probability of x greater than 1. Correct? So what will be this particular value equal to? So here this value we got it as 0.5 into 0.2, and probability of x greater than 1 we got it as 0.4 or 2 into 0.2. Correct? So I can cancel 0.2 and 0.2. So what I am left with? I am left with 0.5 upon 2, which is nothing but 0.25. Okay, so this answers the fourth part of the question. And with this, we come to an end to this particular question also. Hope you have understood the question, enjoyed the video, and hope you found out the video was useful. If yes, then please like the video, help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.